Today let's explore what a system of 3 variables and 3 equations will look like. First, the solution to the system is going to be the ordered triple that makes all equations true. So again, the ordered triple that makes all equations true. Now, we use an ordered triple just like we do an ordered pair. So no matter what variables you're using, you can know how to write the answer. For example, if you had the variables a, b, c, you would write in order the solution as a, b, c. X, y, z, w, x, y, whatever they are, ordered just refers to the order of the alphabet. So let's look at a few examples. The system that we're going to start working with is a negative x minus 5y minus 5z equals 2. The second equation is 4x minus 5y plus 4z equals 19. And the third equation is x plus 5y minus z equals negative 20. Now, when you have a system of 3 variables, you must have 3 equations to work with, but the equations do not always have to have an x, a y, and a z for every single equation. Most of them will, but it is possible to solve the system pretty quickly when you don't have some of the variables or some of these are blanks. So your goal when solving a system of 3 variables is to pick a variable you want to eliminate first. You're pretty much going to go into the same technique as you would for solving a system of 2 variables, where you just pick one variable to eliminate, and then you would have the solution to the other. But with 3 variables, you pick one to eliminate, and then you're going to pick another one to eliminate. So it's just one extra step pretty much. In this case, I'm going to pick the y variable to eliminate, and that is because they are either positive or negative of 5y already. And so what's going to happen is I need to take these equations and I need to split them off into pairs. So one of the equations is going to be used twice. So I'm going to use the first and the second to start my system. And I'm going to separate this out into 2 smaller systems to solve. And so the first and the second are going to be used only once, and I'm going to use the third for each. And this is what you're going to have to do. There's really no other way when you have all x, y, and z listed all 3 times for you to solve the system other than to split this up and solve 2 mini systems. But no matter what, if I've chosen to eliminate y here, when I split it up into pairs, you still are trying to eliminate y. Right? Now you can do this using any of the techniques that you've learned. I'm going to use the addition technique. So I'm just going to add these 2 together. And what's going to happen is if I look at my x's, these are also exact opposites. That's okay. If these cancel and these cancel, I end up with a negative 6z equals negative 18. And that doesn't happen very often. It's not very often that when you set up the system and split it into pairs that the x variable also cancels out. Usually you have x's and z's, but it's okay if that cancels. And so now when I divide by negative 6, I get the value for z. That's actually one of the solutions in my system. But I'm going to hold on to that for a second. All right, now I need to go over to the other pair, and I need to solve for, or get rid of my y's here. So I'm going to get a 5x plus a 3z equals negative 1. And so usually what we do is usually like I said, you have an x and a z. But what this is this gives us an equation in our next system. So whatever happens with these two, you are going to create a new system, 5x plus 3z equals -1, and z equals 3. So your goal when you are eliminating one of the variables is to get two equations where you have a combination of the other two variables left. And so now I have a new system that I can to solve. And when you get down to this technique or this system, you can solve using substitution, elimination, whatever you like. I'm going to use substitution because it already tells me what z is. All right, so whether it's an expression, whether it's a number, I already know the value for z. And so I'm going to come over here, 5x plus 3 times 3 equals -1. So in this case, I get that x equals -2. And so now I've got two of the values in my system. I've got what z is equal to and what x is equal to. And so now I just need to go back up into one of these equations. All right, pick one of them. Let's just use this one. And let's solve for y. So whatever variable you choose to eliminate first is actually the one you're going to get the final answer to last. All right, so I'm going to plug all of these values in that I have. And I'm going to start figuring out my answer. So 5y equals -15, where y equals -3. And so this is your process. It might look a little sloppy, and we're going to try our best not to be sloppy. All right, we're trying to be methodical. But our solution is going to be the ordered triple x, y, and z. And this is our solution. So again, let's just look at this. Again, pick a variable to eliminate, so you can split that up into two pairs. All right. Solve the system however you need to for substitution or elimination. You're going to get a new system of equations that you're going to use to eliminate another variable. So let's just kind of look at one where this didn't happen, where my x didn't cancel, and just kind of go through that process one more time. All right, so if this is my example 2. All right, so we're going to use a -5x plus 3y plus 6z equals 4, -3x plus y plus 5z equals -5, and -4x plus 2y plus z equals 13. Now, when you're choosing a variable to eliminate, you should choose a variable where you have something that's either already exact opposites, one that looks like it's already a multiple of the other, something that you think would be pretty easy to do first. In this case, I'm going to choose to eliminate z. And the reason I'm going to choose that is because z has a coefficient of 1 in front. And so when I split up the first and the second equations, this third one is going to be able to be used for both and be changed. So again, a -5x plus 3y plus 6z equals 4. And then again, I'm going to split up that first and second one. And it does not have to always be split up the first and second and use the third. I'm just choosing that based off of the fact that z has a 1 coefficient. You can split these into any combination of pairs you want. It just depends on how ugly the work is going to start looking when you have to do that. All right, so one thing is to make sure that you copy down the equations in the system correctly. Otherwise, you could be solving using something in good faith that's not actually possible. So again, I'm going to focus on eliminating my z's. And to do that, I would need to multiply this equation by -6. So that's going to change this equation right here into 24x minus 12y minus 6 z equals negative 78. Now, when I solve this, I want to add this bottom equation, the transformed one, to the one above it. And so sometimes once you have already changed the equation, you can lightly cross it out. And now I can add my two equations together, and I'm going to get a 19x minus a 9y, and the z terms cancel, equals negative 74. And again, now you see I have an x and a y left, and so that's going to be, I'm going to wait and hold this to be in my next system. I'm going to come over here, and I need to multiply this one by a negative 5 to be able to eliminate my z. And again, that's going to give me a positive 20x minus 10y minus 5z equals negative 65. And so then I'm going to go through and lightly cross off that system, or that equation. And then I'm going to add vertically. I get 17x minus 9y, z's cancel, equals a negative 70. And so now these two are going to create my new system. And from there, I can choose which variable I want to eliminate based off of what looks easiest to me. And when I look at this, I am going to choose to eliminate the y's because they are almost already exact opposites. Again, remember, you can multiply these by a negative 1, which changes the sign on all of them. And now I get a 2x equals negative 4, or x equals negative 2. And so this is going to be the first value in my ordered triple. And now I need to move my way up. And so now I need to pick one of these to eliminate, or sorry, to substitute, so that way I can solve for the variable I eliminated last. So if I have an x, I need to go up into an equation that has only x and y to find y. So 19 times negative 2 minus 9y equals negative 74. And so then I'm going to start getting some values here that I can solve for. So you're going to go through and just try to find your y. And now, since I found my x, then I found my y, now I need to go back up and find a z. I'm going to plug this into the bottom equation because it looks the easiest to work with. And when you do that, you're going to end up with 16 plus z equals 13, or z is negative 3. So again, your solution is going to be the ordered triple negative 2, 4, and negative 3.